numbers. What are you trying to find? What'd you say?
I said I kind of forgot.
You kind of forgot?
Like,
Alright, so whenever we see the word greatest, does that mean the biggest or the smallest? Alright, when you have something in common with something, you share something, right? So we are trying to find the largest number, and factors are numbers that multiply. So we're actually today doing the reverse of the distributive property. So we are actually going to find a greatest common factor that we can put on the outside of the parentheses, and we're going to do the reverse of the distributive property. So on this one, and then that's factors mean when we're doing the distributive property, we're going to have a factor times another factor to get the original. So the greatest common factor, we want to find the largest number or variable that can be divided by all terms. And we are going to use this today to reverse the distributive property. So I'm just going to give you guys a really basic example. And this is what we're going to work with today. All right, AX plus BX. Okay, we have AX and we have BX. Do you see anything in those two terms that they share? All right, they share an X. So that means that the greatest common factor is an X. So the greatest common factor here would be X because each one of them has an X. So we are going to reverse the distributive property. That greatest common factor is going to go on the outside of the parenthesis. And then you guys are going to tell me if I were to take out that greatest common factor, what would be left? So for AX, if I take the X out and move it here, what's left? An A. Now for BX here, my X, if I take it out, what's left? B. And so you just have to ask yourself, if you were to distribute the X back in, would you get AX plus BX? There we go. That's all we're doing today. We're finding that greatest common factor. We're going to take it, sometimes it'll be a number, sometimes it'll be a variable, sometimes it'll be a mix of both. And then we will write the remainder inside the parentheses. So we're going to take that greatest common factor out, what's left over goes inside. So our first official example, that was just kind of a little general formula. So if I have 6k minus 12. All right, first question, do they share any variables? Definitely not. The first term has a k, the second one does not. So on this one, there's not a variable that they share. But what's a number that you could divide the coefficients both by? All right, could you divide them both by 2? Could you divide them both by 3? Could you divide them both by 4? All right, 4 is not a common factor. Some numbers do have a lot of common factors, but on this one, the greatest common factor that we can divide is 6. So the greatest common factor, we're going to take it out. So let's just think of the distributive property. What 6 times what here would give me 6k? Just a k. And then we're trying to get negative 12 for the second term, so 6 times what would give me that negative 12? Negative 2. And this is what we're going for today. What do you guys think? Easy, difficult? Any questions on that one? All right, let's step it up a little bit. 9m cubed.
Why do you always have to do the white line?
Whenever I do it in color, it doesn't show up as well. You know, say I can show you. It's got lots of filters. This camera's kind of fancy. So if you look at there's like a reverse black and white and like a red and a yellow tint, a blue tint. And then there's like this weird gray, which on your end you can't see it, but it looks like slate. And like, I don't know, it looks really cool from where I can see it, but you can't see it on the projector screen. And then this is the classic. Can you see that? No, you can't see it. I don't know the projector, but the more I've practiced with it, the black and white shows up the most, and I can zoom in a little bit, and I can brighten it up if I need to, and like take the lines away. So out of everything, this is the one that's just worked best, so that's what I go with. All right, so on this next example, there's two terms here. All right, is there a common number that we can divide these by?
9M.
Okay, so,
It just has to be
all right, so do you guys agree we can divide both of those numbers by 9? Now, for the greatest common factor here, they both have an M. But how many like this one actually has 3 M's and this one has 2. So we're looking for the greatest common factor. So how many M's could we take out before we go in the negative? 2. So that 9m squared is going to go in front. And then let's think about that distributive property. All right, 9m times what would give me 9m cubed? Just an m, because the 9's already there. 9 times 1 would give me 9. And then m squared times m would give me m to the third. That's good. All right, now for the second part, we want to multiply to get 18m squared. So what do I need? 9 times what would give me 18? 2. Now, I already have an m squared, so do I need to add any m's here? Nope, that's all you need. And I will tell you guys, when you show your work, don't feel like you have to write those arrows. Now, whenever we are doing the reverse of the distributive property, would you guys agree that what we have here, we're essentially dividing? Have you thought about that? So we're essentially dividing the greatest common factor by each one to find out what's left. Now, I have, do I want to do that one yet? Yes, I do. All right, let's move on to a third one. For a cubed b cubed plus 36 abc plus 24. All right, so we want to find the greatest common factor first. So the first thing we have to ask ourselves, with the numbers, we have a 4, a 36, and a 24. What's the largest number I could divide all three by? I'm going to say, what are you guys thinking? I see some of you I see you guys showing a number on your hands. But what's something I can divide all three numbers by? Somebody's got to talk. 4. So we can divide all of these by 4. Now look at the variables. All right, I see A's, B's, and C's throughout this. Do all 3 terms have an A? Do all 3 terms have a B? Do all 3 terms have a C? So do we have any variables that are common here? Even though these first 2 terms have A's and B's, the third one doesn't, so therefore there's no common variables on that one. So the only thing that we can do on this one for our common factor is take out a 4. And so to find out what's left, we're going to divide every single one of these by 4. So the first term, if I divide by 4, my coefficient's going to be 1. So then that's going to leave me with an A cubed and a B cubed. Because if I distribute that I would get that original. All right, so then what's my middle term going to be? You'll say 4 times what will give me 36? 9. And then the variables are all still there because I didn't take any out. And then my last part, what do I need? What do I need here to get plus 24? Just a 6. And so this is what we call factored form. So if you see something where it says factor the greatest common factor, we're actually taking out the greatest common factor. So it's factored because we're saying this times this whole thing. So factors are when you split it up into multiplication factors, and this is what we're doing here. Do you guys remember in middle school whenever you were given a number and you had to make a factor tree? And you had to split up like 24s into 4 times 6, and then you split the 4 up into 2 times 2 and the 6. You're essentially doing this, but with variables. So it's not as simple, and there's not as many branches on the tree because there's not as much in common. All right, I've got a couple more I want to share with you guys before I let you guys try some on your own. And you'll have to just yell at me if you can't see something because this paper's going to start moving on me. All right, let's see. We've got 50 a squared, b to the 4th, c to the 3rd, plus 25 a to the 5th, b to the 4th, c to the 6th, minus 35 a to the 3rd, b c squared. There we go. That's a lot. All right, on this one, let's look at the numbers first. What's the greatest common factor between 50, 25, and 35? 5. We're gonna take out a 5. All right, now let's look at the variables. We have 3 terms here. Do they all have an A? Okay, hang on just a second. Let me fix something so that way it stops moving on me. Can you guys see that a little better? All right, so on this one, do they all 3 have an A? All right, now we're talking about greatest common factor. How many A's could I take out of each one before I start going negative? 2. All right, now let's look at the B's. We have a B in each term. How many could I take out without going negative? I have 4 in the first one, 4 in the second one, and 1 in the third. So, Kai?
3.
Oh, could I take out 3? Could I take out b to the 3rd if I only have a 1 here? So on this one, the most that I could take out is 1. Now what about the C's? I have 3, I have 6, and then I have 2. How many could I take out without going negative? Just 2. All right, so now we have to figure out what is left. All right, so the first thing we need to do is find out 5 times what will give me 50? 10. Now I have an a squared and all I need is an a squared, so do I need to have any a's here? All right, I have 1b, but I really need 4, so how many do I need to put inside? 3. And I have 2 c's on the outside, and I need 3, so how many do I need to add here? Just 1. Now for the second term, we're trying to multiply that exact same thing on the outside, but this time we need 5 times something to be 25. So what's my coefficient? 5. I already have a squared on the outside, but I need it to distribute to make a to the 5th, so I need a to what power? Now say exponents add here, so 2 plus what would give me 5? 3. All right, how many b's do I need to make 4? 3. And then I have 2 c's. How many do I need to add to make 6? 4. All right, and then the last term, it is a negative, so just bring that negative down. And 5 times 7 would give me 35. All right, I have a squared out here, but I need a cubed, so I just need to add 1a to make a to the 3rd. All right, I have a b on the outside, and that's all we need, right? So do I need to add any more b's here? All right, and then what about the c's? We have a c squared, and that's all we needed, so we are finished. So I know I took a long time to explain that one, but I wanted to make sure that everyone kind of breaks it down to each term. If you guys see here, you had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different ways to make a mistake on this one. So what do you think is more important today? Finishing it in 5 minutes or actually paying attention and making sure that you get them all done and doing them correctly? Yeah, number 2. I always tell my Algebra 2 kids, speed is always better, or speed is never more important than accuracy. No, never, no. Speed is not better than accuracy. You always want to be accurate before you want to be fast. Okay, I've got one more because this is probably the one that I always see people trip up on and I don't know why. So, this is my last one I want to show you guys, and it's only going to be a 2 term. I'm not going to make it super long. All right, is that tall enough? Can you guys all see that? So I have 16x cubed yz to the 4th minus 8xy. Okay, what's the greatest common factor between 8 and 16? You'll say, what number could I divide those both by? 8. Now, what variables do they share? You'll say, what variables do you see in both terms? Just an x and a y. And we can only, since these only have one x and y, that's our greatest common factor, we don't want to go negative. So whenever we write this, our 8xy is going to go on the outside because it's the common factor, but we're going to figure out what to put inside to complete the distributive property. Alright, so 8 times what would give me 16? Alright, how many x's do I need to make x cubed? 2x to the second. Do I need to add any more y's if I already have one? Alright, and then this z to the fourth is needed because we didn't have any z's common there. Alright, now here's the second part. The greatest common factor is 8xy. I need negative 8xy. What do I multiply by to get itself? Negative 1. I don't know why I see a lot of people put zeros there. You know, say you do have to multiply by 1. And so 8xy times a negative 1 would give me that negative 8xy. So sometimes the whole term is the common factor, and so the remainder there is a 1. That was the only thing I wanted to mention. So yesterday did we do evens? Do odds today. So you guys can do odds today since you guys have a second day of this tomorrow. So just work on the odds today, and then tomorrow you guys will have to do them all. But give you guys a little break today, especially to excuse my camera malfunction.